This video is about the integration of nerve messages by temporal summation, and at the end of it, the student will be able to explain how the neuron integrates two successive messages coming from another neuron. In a nerve center, a neuron is connected to a multitude of other neurons. Hence, it receives several afferent messages and elaborates only one afferent messages. So, how does the neuron integrates successive messages coming from the another neuron? The first type of summation is called temporal summation, in which case the neuron integrates messages by temporal summation. Let's examine the circuit. First, the circuit includes one presynaptic neuron and one postsynaptic neuron, and the synapse between these two neurons can be excitatory or inhibitory. This means that the postsynaptic neuron can receive successive EPSP or successive IPSP. In this experiment, we apply successive stimulations on the presynaptic neuron, and we record the variation of membrane potential at the level of the postsynaptic neuron. And in this experiment, each applied stimulation is able to induce an EPSP at the level of the postsynaptic neuron. In the first case, the first experiment, we apply one stimulation at the level of the receptor. As you see, the green spot represents the message due to the stimulation. And when this message reaches the postsynaptic neuron, the membrane shows an EPSP. Now, in the second experiment, we apply two successive stimulations separated by a long time interval. So, at the level of the postsynaptic neuron, we record two separated EPSP. In a third step, we stimulate the presynaptic neuron by two stimulations with a moderate time interval, and we obtain two closer EPSP. Now we apply two stimulations separated by a short time interval. These are the two messages due to them. Look what happens at the level of the postsynaptic neuron. There is summation of the two EPSP. We obtain one EPSP of higher amplitude. And now we apply three successive stimulations separated by a short time interval. Look at the summation. There is summation of 3 EPSP, and the resultant is an EPSP of higher amplitude. And in the last case, we apply 4 stimulations separated by a short time interval. So the 4 EPSP sum up. The resultant of summation is more than the threshold of depolarization of the postsynaptic neuron, and it turns into an action potential. This is the temporal summation.